Okay, so you can graph linear equations, and now it's time to talk about another important sort of form of these things, and that is inequalities. So we're going to start by graphing all the points that satisfy the function f of x equals 2x minus 1. Alright, so I draw a line on this graph, and remember how we talked about in class, not everything has to be labeled if you can make it very evident where your line is going and its slope and its y-intercept. So here we have a line that appears to be 2x minus 1. Now, every point that satisfies 2x minus 1 is going to be on this line. Nowhere else will you find points that satisfy this function. Alright, any point not on the line is not going to satisfy the function. So this is kind of key to all the families of functions. All of their satisfactory points, no matter how curvy that line, all satisfactory points lie on the line. Alright, and that just means when you pick any point on the line and plug it into the equation, you get a true statement. So now let's graph all the points that satisfy f of x is greater than or equal to 2x minus 1. This should be pretty straightforward because we've already graphed this line. So once again, I throw down a small coordinate plane and put the graph on there. But now let's consider this greater than or equal to feature. Now every point above this line is going to satisfy my function. So this point's going to work. So will one over here. So will one way up here. Any point that falls above this line is going to satisfy it. Any point that you pick is going to make that inequality true. It's not just restricted to points on the line. So any point above or on the line is going to work in this function. Alright, so when you consider an equality, all solutions fall on the line. When you consider an inequality, however, solutions can be on the line or above the line, and this is a new vocabulary term. It's called the solution region, because this forms like a physical area that you're looking at on the plane. So let's recall a few more things from your pre-algebra days. First, I draw a number line and install the point 4 on there, with a colored-in bubble and an arrow to the right. Now this means that x is greater than or equal to 4, or that 4 is less than or equal to x. However you phrase that, it's a valid mathematical statement, and I'm going to accept it. Now remember the other kind with the hollow circle? This just means x is greater than 4, or 4 is less than x. But x cannot be equal to 4. It's mandating that x be above the 4. So, how do you reckon we can represent this with our two-dimensional coordinate planes? Well, first off, if you have a solid line and it's shaded above, that's going to be greater than or equal to. The difference comes when you just have greater than. And to represent that, we use a dotted line. So the difference between having a greater than or equal to and just having a greater than, when it comes to the plane, is going to be whether or not that is a solid line.